All right, folks, I was looking through my video archive and I realized I didn't have an electroscope video, so here we go. What we're going to do in this video is a couple of things. One, we're going to go over the structure of the electroscope, which is what this is. We'll also look later at a much more classical version of an electroscope, the ones that were used in the early 20th century and late 19th century. No. Yes. Okay. So we're going to go structure, function, and then we'll look through all of the different parts of this in terms of looking at polarization, charging by conduction, grounding, charging by induction with the electroscope so you can see it, in case you were not here for this. So here we go. We have an electroscope. So the electroscope is this metal device, but very specifically we have to talk about what is the electrical system. So we have this top bit, which is called the plate. Sometimes on the old ones, you can see here it's not a plate, it's a knob. So the plate or the knob. And the plate or knob is made out of metal. And then you see this part here, and that's called the stem. For reasons that doesn't make much sense here, I'll make that make sense in a minute. And the stem is also made out of metal. And then there is this part as well that is able to rotate. This rotating part is called the vane, V-A-N-E, like a weather vane, right? And the vane can rotate away from the stem, or we say deflect from the stem. Now you notice that the stem and the vane are both made out of metal, meaning charge, electrons can flow between the stem and the vane. What might be a little bit more difficult, so I'll zoom in here as you see this bit here, that's made of plastic. So that means it's an insulator. So that means it is disconnecting the plate and the stem from this ring. So this ring is only there to suspend this, so it's electrically insulated from the rest of the environment. It's really hard to see, but if you look there, you can see there's a screw inside there. That means that the plate is connected to that screw, which is connected to the stem, meaning the plate is electrically connected to the stem vane system. So our electrical system then is the plate stem vane. All right, so that's important. So here we go. I have a black rubber rod here. When I prepare this with fur, it becomes negatively charged through charging by friction. So the first thing we're going to do is see what happens to the electroscope when a charged object is brought near the plate. And what you can see pretty clearly here is that that vane deflects temporarily. So only in the presence of the charge does it deflect. Now, just to show you this, I have a glass rod here. Rub it with silk. We know this is positive now from the standards, and you can see that this also deflects and also temporarily. So I'm just going to pick this random wood thing on the table, bring that close to the plate, and nothing happens, just to show you here that the electroscope can be used to detect charge. Anytime charge is brought near the plate without touching it, the vane will deflect temporarily. So if the vane deflects, the object is charged. We don't know if it's charged positive or negative, so it detects charge. The second thing hopefully you noticed is in the with the glass rod, when I brought it close, it deflected more and more quickly. That gives us a sense that the glass rod has a higher magnitude of charge than the rubber strip does. So what the second purpose of an electroscope is, in order to figure out the relative magnitude of charge. I don't want to say the magnitude of the charge because it can't quantify for us the size of the charge, only if it's bigger or smaller than another charge. The more it deflects and the more quickly it deflects, the stronger the charge that was brought. So why is that? What's going on? So let's talk about negative rod brought close. I have to prepare it again. Okay, boom. So this is negative, and we have this electrical system, so I have a strong negative charge brought near this. So what I'm going to get here is, and you could probably hear this in the phrasing of what I used before, since this vane only temporarily deflects in the presence of the charge, it's a hint to what's going on is polarization. So the strong negative charge here, electrons, some of them in the plate, want to get away from this strong negative charge, so they go down into both the stem and the vane, right? So that means the plate temporarily is positive, the vane and the stem are both negative. Since these are both negative, the vane would deflect away from. And then when I take the charged object away, the redistribution goes back to even throughout, which is why that happens. So the first two purposes of the electroscope are achieved through polarization. Perfect. Okay, good. So now, here we go. Charging by conduction. So I can charge by conduction simply just by touching. And now what you'll see is something different. It takes a little bit of time to get to the equilibrium, but now what you can see here is the vane is now permanently deflected from the stem. And that's how you know that the electroscope is charged. Now it's conduction, so we've talked about this before. If this was negative and I touch this, charge is going to flow from the high region of negative charge to the less concentration of negative charge because this thing was neutral. So this thing became negative in that process. Great. So there we go. So how do I get this thing to become uncharged? I need to ground it. I need to create a conductive pathway between the electroscope and the earth. Very simply, there it is. So it's now uncharged, this electroscope. I became the conductive pathway. I'm made mostly of water, my nervous system. I'm a much bigger object than this is, whatever you want to say. That's why I can serve as the ground. So I touch this, the excess electrons flow to me and into the ground. Show you that this also happens with the positively charged object. So positively charged, here, touch. Oh, just touch, there we go. And we can see that permanent deflection. So, okay, good. So that permanent deflection means that this thing is charged. Now it's charged positively. So when I touch this positive thing to that, the electroscope is now the thing with the higher electron concentration. This, some electrons flowed up onto this. So now this has a lack of electrons, so it is positive, which is why I'm getting the deflection, because that's positive, and that's positive. Once again, I can ground it. It goes to neutral, but in this case, when I ground it, electrons are coming from me onto this because I have a larger electron concentration than this does, and I have so many more electrons than this does that I can give up electrons without changing my status as a neutral object, because I'm also connected straight to the ground. Okay, so that is charging by conduction. That is charging, or that is the grounding process. The last thing is charging by induction. Well, actually, no, before we do charging by induction, the third purpose of an electroscope is to determine the charge of an unknown charge. So here we go. I'm going to charge the electroscope. So now the electroscope has a known charge. It is negative, because I use the negative object to charge this. Watch what happens when I bring another negative object close to the plate now of this negatively charged electroscope. All right. Do you see that it deflected more from that new equilibrium position? Then it goes back to that new equilibrium position. So a same charged object, when brought near a charged electroscope, the electroscope will deflect more. We don't want to say deflect because it's already deflected. Deflect more when it's the same flavor. But now, when I bring the positively charged object, notice that it deflects less. I bring it away, it goes back to that new equilibrium position. Bring it close, it deflects less. So if I have a charged electroscope, by bringing an unknown object near the plate, if the unknown object makes it deflect more, it has the same flavor as what the electroscope was. If it deflects less, it has the opposite flavor. I could also just charge the scope with the unknown by conduction. Then I know the scope has whatever flavor that the unknown has, and bring two knowns nearby and see which causes it to deflect more and less, and use that same logic. So there's the electroscope. Let me ground this. Okay. The last thing, charging by induction. Okay. So take my negative object. Here we go. I'm going to bring it close without touching. Now I'm going to ground it, unground, and there you go. And notice it is charged. It is permanently deflected. Okay? So use a negative object to charge by induction. Watch when I bring this negative object close to the plate now, and it deflects less, thus proving that the electroscope got charged positively through charging by induction. Because when you charge by induction, you end up with the opposite flavor as what charged you. So the charging by induction video will go through How the hell does it all happen? I just wanted to show that it is true with the electroscope and how I can use the electroscope to determine the charge of an unknown, this deflecting more or less with the charged electroscope. Okay, let me just get rid of that. The last thing I want to show you is this old-timey electroscope. So you can see that knob, that same stem, but do you see there's like two floppy things on the bottom there? Those are leaves of gold, right? I know, ooh, gold. Anyway, that's why this thing was originally called the stem, because the original ones here had these two leaves at the bottom. I want to show you what happens when I bring a charged object near to the knob. So take a look at those leaves. See, it'd be easier if I give you a better background here. Oh, that's not showing it very well. Let me see if I can get a better charge on that. Okay, there we go. It's hard with the glare there. Can you see that the leaves kind of go outwards like that? So rather than the vein deflecting, the two leaves become the same flavor of charge and they diverge. Okay, so they look like leaves on a tree, which is why it's a stem. Okay, so that's the old-timey. Our new modern electroscope is a little bit easier to see, which is why we use these days rather than these old ones. But I did want to show you the structure of that. So that is how you use the electroscope to do the three purposes of the electroscope. And we demonstrated all of our charging processes as well as polarization and grounding, which are not charging processes, using the electroscope.